In last class, we discussed some properties of rational numbers. Today, we'll continue the next concept of this chapter. In previous class, we learnt about commutative property for whole numbers and associative property for whole numbers. Now, let's consider closure property for integers. First, let us consider the addition of two integers. When we add two integers, let's say we are having an integer -6 and we are adding it to 5. Both are integers. We get the result as -1. Now -1 is also an integer, so we can say that closure property holds good in case of addition for integers, or we can say integers are closed under addition. What about subtraction? When we subtract two integers, let us say we are having 7 and we are having number 5. So 7 minus 5, we are going to get 2. 2 is an integer because integer includes positive number as well as negative numbers. So in subtraction also we find that closure property holds good, or we can say integers are closed under subtraction. What about multiplication? When we multiply two numbers which are integers, let us say 5 multiplied by 8, the result is 40. Again 40 is also an integer. We find that closure property holds in case of addition, subtraction and multiplication. So once again I will repeat, closure property holds good in case of addition, subtraction and multiplication. What about division? We take an example here. Let's say 5 divided by 8. Now 5 divided by 8, we are going to get a fraction which is 5 upon 8. We know that 5 upon 8 is not an integer, it is a rational number. Since it is a rational number, we can say that closure property does not hold good in case of division, or we can say integers are not closed under division. Now let's talk about next property, that is commutative property for integers. Let's take an example. Let's add two integers. We take 2 and -5. Let's add these two integers. Now let us add these two integers. 2 plus of -5, that is plus into minus, it becomes minus. 2 minus 5 is equal to -3. Now let us interchange the position of these integers. We write -5 first, then we write 2. -5 plus 2, what is the result again? The answer is -3. Therefore, we conclude that commutative property holds good in case of addition, or we can say addition is commutative. In case of subtraction, we find that 5 minus of -3, is it equal to -3 minus 5? Here you can observe that minus into minus, it becomes plus. So 5 plus 3 is equal to 8, and -3 minus 5 is equal to -8. Here we find that LHS is 8 and RHS is -8. So LHS is not equal to RHS. So we can say that commutative property is not true for subtraction, or we can say subtraction is not commutative. Again, let us say for multiplication is minus 4 into 7 is same as 7 into minus 4. When we multiply two integers, minus 4 into 7 gives you minus 28, and 7 into minus 4 also give you minus 28. So I can say that commutative property holds good in case of multiplication for integer, because we are getting LHS is equal to RHS. So we can say multiplication is commutative. Let's take for division. Is 5 by 7 is same as 7 by 5? The answer is no. 5 by 7 is 0.71 and 7 divided by 5 is 1.4. They are not equal. LHS is not equal to RHS. So we find that commutative property is not true in case of division. Let's talk about third property, that is associative property for integers. Now we all know what is associative property. Here again we play around with the order of the integers. Now let's take example. First we will talk about addition. So in this case, let us consider three integers minus 2, 3 and minus 4. If you add them in this order, minus 2 plus bracket 3 plus of minus 4, this is one way. You can add the integers, there is also another way. Minus 2 plus 3 bracket plus of minus 4. Basically here first we need to solve the brackets, then add the sum to the first integer. 3 plus into minus 4, plus into minus is equal to minus. So 3 minus 4 is equal to minus 1. Minus 1 minus 2 is equal to minus 3. This is LHS. The answer for LHS is minus 3. Then come to RHS. Minus 2 plus 3 is equal to 1, and plus of minus is minus, so minus 4. 1 minus 4 is equal to minus 3. It is RHS. So LHS is equal to RHS. LHS is also minus 3 and RHS is also minus 3. So associative property holds good in case of addition for integers, or we can say addition is associative. Now let's try for subtraction. Let us take three integers 5, 7, minus 3. In this case 5 minus bracket 7 minus 3 is same as 5 minus 7 bracket minus 3. Here also same, first we need to solve the brackets, that is 7 minus 3 is equal to 4. 5 minus 4 is equal to 1. So we are getting LHS as 1. Again in RHS, bracket in the bracket 5 minus 7 is equal to minus 2. Minus 2 minus 3 we are going to get as minus 5. LHS is 1 and RHS is minus 5. We are getting different results. So associative property does not hold good in case of subtraction, or we can say subtraction is not associative. Again let's try for multiplication. 5 into bracket minus 7 into minus 8 is the same as 5 into minus 7 bracket into minus 8. Here also we need to solve the brackets. Minus 7 into minus 8 will give us 56. Minus into minus is plus. So we are going to get plus 56. Then 56 into 5. The result is 280. LHS we are getting as 280. And 5 into minus 7 will give us minus 35. Why it is minus 35? Because plus into minus is minus. 35 into 8 again will give us 280 because minus into minus is plus. So we are getting plus 280. Here also same thing, LHS is equal to RHS. So we can say that associative property is true in case of multiplication for integers. Lastly, if you look at division, minus 10 divided by 2 bracket divided by minus 5, is it equal to minus 10 divided by bracket open 2 divided by minus 5 bracket close? The answer will be no, because if you solve this problem we are not going to get LHS is equal to RHS. We are not going to get, LHS is different and RHS is different. So it is not true for division. So in today's class we learned about commutative property, closure property and associative property for integers. Students, take some more examples and try at home or practice at home. Thank you.